All right, number one, we are supposed to give a couple of ordered pairs. So, oops, that should be an X, sorry, and a Y. It'd be nice to plug in 0, be nice to plug in 1. You plug in 0, 3 to the 0 is 1, 3 to the 1 is 3, 0, 1, 1, 3. Let's answer some of these questions first. So our domain is going to be all real numbers. Your range, let me come back to that as we talk about the asymptote in a moment. Part B, any transformations? No, there are no A, H, or K, so I would say none. This is exponential, so it has a horizontal asymptote. And the horizontal asymptote has an equation of y equals. It defaults to 0 unless you have a K value. I didn't, so it is a 0. So I have this asymptote right here, which now that I understand that, I can finish the graph. And now I can come back and finish the range. I see that the y value has to be greater than or above the asymptote of 0. Number 2, my goal is to have an exponent of 0. I would have to have an x value of -3 to make that happen. If I have a -3 up there, my exponent's 0. 1/5 to the 0 equals 1. So 4 times 1 is 4, minus 1 is 3. Then I'll go ahead and try a -2. It gives me an exponent of 1. 1/5 to the 1 is 1/5. 4 times 1/5 is 4/5. 4/5 minus 1 is -1/5. -2 and -1/5 is about there. I'm going to jump down to my asymptote. Y equals -1 because it shifted down 1. So now I can get my asymptote in there and finish my graph. So my domain, all reals. My range is that y is greater than -1. There is, we went left 3, we went down 1, and because of that 4, we had a vertical stretch. Number 3, plug in 0, plug in 1, so I get a 6, 0, 6, and then I get 3 when I plug those in. My asymptote is going to be at a 0 because there's no K value. So my domain, all real numbers, and my range is that y has to be above 0. We didn't go left or right, but that 6 does give us a vertical stretch. In the next section, we jump to logarithmic functions. And here the domain is restricted, so I can't pick just anything for x's, and I cannot pick 0, because you can't take a log of 0. Since this is a base of 3, I'd like to have powers of 3 when I pick my x's. So I'll go with 1. That works out well. Then I would have 3. If I kept going, I could think about 9, 27, etc. Or I could think of 1/3, 1/9, 1/27, etc. When I plug in 1, log base 3 of 1, that's 0. It's the 0th power of 3. 3 is the first power of 3. So I get 1, 0 and 3, 1. Logarithms have vertical asymptotes. So it's an x equals equation. By default, it's 0 unless you have an h. I do not have an h here, so it is 0. So because I've drawn that, I can go ahead and connect my points. So domain, x had to stay to the right of the asymptote of 0. So x had to be greater than 0. Your range is all real numbers. It goes up and down forever. There are no transformations on this one, no A, H, or K. The next one, it's the same thing, but it's shifted up 2. So I can still plug in 0. I can still plug in, oh, sorry, not true. I cannot plug in 0. You can never take a log of 0. You can do a log of 1, and we can do 3 since it's a base of 3. Log base 3 of 1 is 0, but now I'm adding 2, so I get a 2. Log base 3 of 3 is 1, plus 2 is 3. So 1, 2, and 3, 3. I still have a vertical asymptote because it's a log. I do not have an h value, so it doesn't get shifted horizontally. So x equals 0 is still my asymptote. Now I can connect the dots from my graph. Domain, x is greater than 0. And my range is all real numbers. This one does have one transformation. It shifted up 2. Notice it looks the same as the last graph, but it's 2 units higher. Number 6, now I have an h value in there. So now if I want to end up with a 1 in the parentheses, I should use a -1 for x. It's a base of 3, so I'd like to have a 3 there for my next one, so my x value needed to be 1. So plug those in. -1 plus 2 is 1, and log base 3 of 1 is 0. 1 plus 2 is 3, and log base 3 of 3 is 1. So -1, 0, and 1, 1. It is a vertical asymptote. It did get shifted 2 units to the left. Remember, your h there, you have to do the opposite sign. It says +2, so we're going to have a -2. So now I can draw that. My domain, x has to be greater than -2, because it got shifted. And your range is still all real numbers. The only translation here is that it went left 2. That's the end of the graphing. Now we have exponential functions. It tells us they're exponential. I can see that as x went from 0 to 4, that my y value grew. So I know it's exponential growth. My initial value is 8. That's like my a in the equation. At this point, I don't know what my b is to the power of x. And so what I do is I take the order pair that doesn't have the 0, call that my x and my y. So plug them in. So 2048 is equal to 8 times b to the 4th power. So I would first divide by 8, get 256. Then to get b, I'd want to get rid of the 4th power, so I would do the 4th root. Typically, because it's an even root, I would have to do plus or minus. But on these exponential problems, we're only dealing with positive bases. So I'm going to ignore the negative possibility here and say that my base had to be 4. So now I can give the final equation. Y equals 8 times 4 to the power of x. And that's it. Number 8. Here we have an x value of 0, so there's my a, -0.2. I have a base number to a power of x. So now plug in that other order pair as your x and your y. So let's divide by -0.2. Let's see, 15.625. To solve that, because it's a negative in there, I might approach this a little bit differently than I normally would. I'm not necessarily going to do a cube root. I can do it to the power of the reciprocal, -1/3. That way -3 times -1/3 becomes just a 1, so B. So over here I have to do 15.625 to the -1/3. You can do that on the calculator. You get 0.4. So y is equal to -0.2 times 0.4 to the power of x. You want those in fraction form instead of decimal form, that's perfectly fine. Be -1/5 times 2/5 to the x. That would be fine. But their answers were all in decimal form, so I'm okay with being consistent. Now we just rewrite. So 3 to the 5th equals 243 would be the exponential form. Number 10 would be 5 to the -2 is equal to 1/25. Starting with the number 11, we write it in logarithmic form. So log base 2 of 8 is equal to 3. And on number 12, it would be log base 1/3 of 1/9 is equal to 2. So that section is all just rewriting in the opposite form, knowing what numbers go where. Starting with number 13, we evaluate. No need for a calculator here. These are all going to work out nicely. 25 is a power of 5. It's the second power. 5 squared is 25. So 2 is our answer. Number 14, it might work nicer if they were in the opposite order. If I had the 5 as the base and 125 as the number, I would say it was the third power. But here they're in reverse order. So it's the third root, 1/3. 125 to the 1/3 gives us 5. Number 15, if you ignore the fact that it's a fraction, 4 to the 3rd is 64. And because it was in the denominator, that just means the exponent needed to be negative. So it was 3, but it had to be negative, so -3. Number 16, it's a combination of the ideas of 14 and 15 together. To get from 27 to 3, we had to do a 1/3 power. So we'd write 1/3, and because it's in the denominator, it needed to be negative, so -1/3. Then we go to the second page. Part A, we have to write an exponential function for this scenario. They're telling us that t is starting in 1985. We can consider that when time began, so that means our initial amount of cell phones was 285. That's the A. And then that was the number of subscribers, and then it's increasing, so it's exponential growth. So 1 plus your rate, 75%, you have to change it to a decimal. So 0.75 to the power of, they say to use t. Understand t means the number of years since 1985. So there's the answer to part A. If you want to simplify your parentheses and call it 1.75, that's perfectly fine. So now use that model to predict the number of subscribers that there would have been in 2005. You didn't need to change that parenthesis to 1.75. You can leave it as 1 plus if you'd like, but if it's easy to do, maybe it's worth doing right there. So if time started in 1985 and now we're in 2005, 20 years have elapsed. Oops, there's a message here, sorry. So I'm going to use an exponent of 20. And then plug that in the calculator. I would plug it in all in one step. You're more likely to mess it up if you do it in chunks on the calculator, do it one piece at a time. I would encourage you to do all of it at once. And so we see it's increased, it's increased exponentially. But there's 20,682,000. And if we round to the nearest person, so that would be relevant in this case, be 633. So 20,682,633 subscribers. Where did I get the what? The 20 up here? So we're talking about 2005. T is the number of years since 1985. So 20 years have elapsed. So number 18, we're talking about ibuprofen. So we started with 400 milligrams. The amount is decreasing. The amount in your system is going to decrease, so we're going to use 1 minus instead of 1 plus. 29% as a decimal is 0.29. To the power of, they said use x here, and x is going to represent the number of hours. There's our model. Now, part B, so how much ibuprofen is left after 6 hours? So plug 6 in for x. If you want to simplify that parentheses, I just messed up, 0.71. You do not have to simplify that. The calculator doesn't care if it was simplified or not. If you're going to simplify it, make sure you simplify it correctly, please. You get 51, let's go to nearest hundredth maybe. So 51.24, we're talking about milligrams of ibuprofen. Number 19, we're investing money. Compound interest. So we have to use our compound interest model. So we're initially investing 20,000. 1 plus your rate as the decimal is 0.052, but we have to divide it because we're compounding. How many semi-annuals are there in a year? 2. So the n value is 2, and that goes in. You divide your rate by that, and you multiply the number of years by that. So 2 shows up in both of those places. We're talking about 3 years. So we're actually getting interest 6 times. If you're getting it twice a year for 6 years. So we can type that in, 20,000. 1 plus 0.052 divided by 2. Close the parentheses, raise it to the power of 6. And we see your balance should be $23,329.97. Number 20, we have another investment and compounded quarterly. What's our end value going to be if it's quarterly? 4. So 40,000. 1 plus, our rate is 14%, so 0.14. It's a good investment. Compounded quarterly. So divide the 14 by 4 and multiply the number of years by 4. This is a 6.25 year investment. Like you're getting interest 4 times a year. So 40,000 times 1 plus 0.14 divided by 4 to the power of, that ends up being 25 times you get interest. 4 times a year for 6.25 years. You get a balance of $94,529. And if rounds nearest penny, which would be relevant to the money situation, you'd have 80 cents. Number 21, we have another compounded monthly. Monthly, there are 12 months in a year. Our end value is 12. $440. 1 plus 0.058 divided by 12. And 12 times a year we get interest for 8 years. So 440 times 1 plus 0.058 divided by 12. And that's all taken to the power of 96. We would have $699.00. Then we get into solving equations. On number 12, I see that both base numbers 4 and 64 can be expressed as powers of 4. So I would leave the left side alone, but I would change 64 to 4 cubed. Notice I haven't changed its value, but instead I've written it as a power of 4. On the right side, since I already had an exponent there, I have to multiply that exponent by 3. 4 cubed to the power of x minus 3. The 3 gets distributed, becomes a 3x minus 9. Now that I have the same base numbers, the exponents must equal each other. So x plus 35 must equal 3x minus 9. Solve this. I'm going to subtract x from both sides, and I'll add 9 to both sides. So 2x has to equal 44, therefore x would equal 22. No domain restrictions on exponentials, so that should be just fine. Number 23, 1/2 and 16 are both powers of 2. 1/2 could be expressed as 2 to the negative 1, and it's to the x minus 3. Meanwhile, 16 is expressed as 2 to the 4th, and it's to the power of 3x plus 1. Distribute those exponents, so 2 to the negative x plus 3 is equal to 2 to the 12x plus 4. At this point, our exponents equal each other. I'm going to add x to both sides, and I'm going to subtract 4. So 13x is equal to negative 1. So solve for x, we divide by 13, I get negative 1/13. Once again, no domain restrictions on exponentials, so that should be the answer. Number 24, we get an inequality. They're both powers of 6. 136 is 6 to the negative 2. 216 is 6 to the 3rd. So 6 to the negative 2x minus 16 is less than or equal to 6 to the 3x minus 9. That means negative 2x minus 16 must be less than or equal to 3x minus 9. I'm going to subtract 3x from both sides. I'm also going to add 16 to both sides. Then I have to divide by a negative 5. It is an inequality, so that does switch the inequality sign when I divide by a negative. So x has to be greater than or equal to negative 7/5. No domain restrictions to worry about there. Then I get into logarithmic equations. So I'm going to get rid of a log on number 25, I'm going to exponentiate with the base of 4 because I'm trying to get rid of the log base 4. So 4 to the left side equals 4 to the right side. Left side just becomes then 4x minus 20. The right side is 4 to the 5th power. 4 to the 5th power, it's a big number, it's 1024. So then add 20 to both sides. 1044. Divide by 4. We get 261. We do have concerns about domain restrictions on logarithmic problems, so we should check this answer. Plug it back into the log. 4 times 261 is 1044, minus 20 is 1024. It's not a negative number, and log base 4 of 1024 equals 5, so that's perfectly fine. Number 26. There's logs on both sides, but if I exponentiate using a base of 9, it eliminates both logs at the same time, leaving me with 3x squared is equal to 2x plus 1. This is probably going to be a factoring type of problem, so I'm going to bring everything to one side so that it's set equal to 0. And then I'll try to factor. So we get 3x plus 1 and x minus 1. So then solve both of those. If 3x plus 1 equals 0, you'd have to subtract the 1 and then divide by 3, so we get negative 1/3. And if x minus 1 equals 0, we get positive 1. We do need to check to make sure both of those answers work. When you plug in negative 1/3, square first. Negative 1/3 squared is positive 1/9 times 3 gives me positive 1/3. And when I plug it on the right side, 2 times negative 1/3 is negative 2/3, plus 1 is also 1/3. So it does work. It doesn't give me a negative log. When I plug in 1 squared is 1 times 3 is 3. On the right side, 2 times 1 is 2, plus 1 is 3. Also gives me a positive log. Both of them match. So both of those answers work. They would, if you plug them in and they give you positive logs that don't match, like maybe you get log of 5 equals log of 7. Well, that doesn't work. It doesn't mean it was extraneous. It means you made a mistake. So they should, both sides should be the same thing, and they need to be positive. If they're both positive but don't match, I would check your work. Okay, number 27, an inequality. I'm going to exponentiate. The base of 7 eliminates both logs at the same time. So 8x plus 5 is greater than 6x minus 18. Subtract 6x from both sides. Subtract 5 from both sides. Divide by 2. It gives me x is greater than negative 23/2. That may or may not be correct. At least some of it is probably correct, but I don't know if all of it is, because not every number can be plugged into a log. So on the last problems, 25 and 26, I would encourage you, when it's an equal sign, just plug your answer in. But on an inequality, that changes because I can't plug in every single number greater than negative 23/2. So this is where I check my domain. Let me change colors. Maybe something darker than that with blue. So I'm going to check my domain. I actually have 2 logs here, so I need to check them both. I was taking the log of 8x plus 5, so it must be greater than 0. And if I solve that, I see that x has to be greater than negative 5/8. But also check the other log. 6x minus 18 must also be greater than 0. So 6x must be greater than 18, which means x must be greater than 3. We have 2 different domain pieces, and both of them have to be true. So in order for both of them to be true, the numbers have to be greater than 3. If they're greater than negative 5/8, they might not be greater than 3. Well, both of them have to work, and this second one is more restrictive. So there's my domain piece. Only the numbers larger than 3 work in the domain. Now go back to our actual answer. It said greater than negative 23/2, which is negative 11.5. Are all of those numbers greater than 3? No, because it's negative. So some of them don't work, and they don't work until we get up to 3. When it's larger than 3, it works. So now we have to restrict that domain, or restrict our answer because of the domain. And it turns out that the domain x greater than 3 happens to be our answer to that problem. Anything less than 3 didn't work in one of the logs, and so we had to throw them out. All right, let's check number 28. Last problem, exponentiate with the base of 10. X minus 3 is less than 10 squared. Well, 10 squared is 100. So x is less than 103. And then I need to check my domain. There's only one log this time, so only one domain restriction I have to be concerned with. X minus 3 has to be greater than 0, so therefore x has to be greater than 3. So now we compare our answer of numbers that are less than 103. Are all of those greater than 3? No, but some of them are. So we're looking for the numbers that are in between 3 and 103. Both of them are open intervals, so no equal to signs here. So it has to be less than 103, but also has to be greater than 3. And there's our answer.